In this presentation, I will introduce you to transactions in databases. And transactions is something that we usually don't think of when we use SQL and we make queries to our database. We're just thinking of it's a query, we want to retrieve some data. But in transactions, we can see, it is a possibility that we can view it this way, that we send a query and this query will affect several tables, and sometimes we need to take care of this consistency or concurrency we might experience when we use databases. So let's say this query will affect two tables, and perhaps there are some constraints that we have not put into our design that we think of this should be a part of the business rules, and we expect the developers to respect these business rules. And if they don't respect these business rules or constraints, we might get some error or wrong data or misuse of data. And usually we see transactions in large systems, for example in banking systems, where it's necessary to trust the transactions. So if we want to transfer money from one account to another, we want to make sure that actually there is an account we can transfer to. And if there isn't an account, then we have to roll back the transactions. So in this presentation, I will use these four tables as my shop case, and this is the diagram of the case. We have the customer, and the customer can place an order in the shop, and the shop order will contain a number of order lines. That is the product and the price of the product and the quantity that we want to order, and the price or the total price of the price and the quantity multiplied together. And of course the order line is also related to the product. So we have a product name, description, price, and then the stock. And the stock is how many of this product do we have in our warehouse or wherever it may be. So in this example, a customer wants to buy a product, and we can break down this process of buying a product into a few steps. And the first step will be create a row in the order table. We want to create an order, so we are able to specify this is the customer, and the order will then be the main part that will hold the lines of the order. And then we want to create a row in the order line table for each of the purchased product, and then we want to decrease the stock of the product. So we know how much do we have in our warehouse. And let's have a look at the first step. We want to create a row in the order table. So in the order table we create a row, no problem with that. We just have to specify who's the customer, so we have this relationship in place. Now we want to create a row in the order line table for each of the purchased products. So in the order line table we create two rows, and for each of these rows we want to decrease the number of items in the stock. That means if we have 5 computers before a customer comes and buy one, then we should decrease the product stock with 1, so now we have 4. So it shall reflect what do we have in our warehouse. So in our product we find the product number 1, and then we decrease the number with 1, the product stock with 1. But what if the product stock is less than 1? Then we have to convey a message to the customer that the product is sold out. Or if we have more than 1, we have more than 0 if we don't have an empty stock, then we want to decrease the stock by the quantity that the customer has purchased. So what happens if the product is sold out? Then we don't want to decrease the stock. And when we don't want to decrease the stock, we actually don't want to create a row for each of the purchased product, because in this case, the customer will only place the order if everything can be purchased in one order. So when the customer cannot purchase everything, he would like to delete the order again. So don't create a row in the order table. So we need to check up on all these business rules, or put in these rules into action. So if we have a transaction that we have to roll back, then we have to use the rollback feature in the database. So we will roll back the transaction, and when we roll something back, the database server will step backwards and then delete what it has done, so everything is neat and fine as it was like before we went into the database and tried to create the rows, create the order lines, and decrease the stock. And then we will of course convey the message that the product is sold out and the customer cannot place the order. So what if everything goes correctly and everything is a success? Then we want to commit the transaction and send some data back. So we have two topics here. The first one, two keywords. The first one is rollback and the other one is commit. And hopefully most of the time we will use commit, so all these transactions can be fulfilled. And it will be like when we try something, and then we will have the possibility to catch an error, and perhaps you know the phrase try catch, and this is actually the same thing we're doing here, just in a database. So when we look at transaction and transaction theory in database theory, we might look at an acronym called ACID. And ACID is 4 words, or 4 keywords. It's Atomicity, that which I will talk about in a minute, and it's consistency, and it's isolation, and it's durability. So what do we mean by these 4 keywords? Let's look at atomicity first. It means all or nothing. So we can look at a query or a transaction as many pieces of one transaction. Like we want to select something, we want to insert something, perhaps we want to update something, and this is all the atoms in this transaction. And everything has to be successful, otherwise we don't do it. So it will be all or nothing. So it's commit or it's rollback. And as we saw here before, it's like if we don't do this, we don't do the other steps the previous steps. So we will make a rollback. The next one, the C, is consistency. And consistency means respect the business rules. And for example, we have the relationships and we have some constraints. And these relationships and constraints we have to respect. Otherwise, it will be perhaps not consistent data, and they will not be reliable. We cannot trust what we will take. For example, if we want to, like I will show in a minute in the walkthrough of how to make this transaction, I will show that if we don't have a constraint between 2 tables, then we might violate the business rules. For example, if we create an order for a customer that doesn't exist. So we have to be sure that this transaction, the design of this transaction, will respect the business rules. And this would be something like, okay, we could create a row and we could create in the order table, and then we can create the order lines. And for each of these, it was okay to decrease the stock. We didn't go below 1, so below 0. So everything is okay. The next, or the third letter, is isolation. And isolation means trusted parts of the transaction. That means it has to be reliable parts that we will conduct. And let's have a look at this stock algorithm. We want to first ask how many items of the product do we have in order to be able to decrease the number in the stock, or the items in the stock. And if the stock has more than the customer wants to purchase, then we decrease, and then everything is okay. Otherwise, or else, we don't decrease, and we will then roll back everything. So in this case, let's have a look at this scenario that we have 2 customers who wants to buy the same product, or it could be 2 customers who want to, if it's not a web shop, it could be a booking in a restaurant, or it could be a ticket office that perhaps a concert have to buy tickets for a concert, and it's possible to buy these online, and then 2 customers perhaps want to buy the same places in a concert hall, or whatever it may be. Let's say we have 4 items back, or 4 products in our stock, in our warehouse, and then one customer comes and asks, how much do we have in the stock? And we say to the customer, we have 4. Then another one comes and says, how much do we have in the stock? And we say, we have 4. Then the first one comes again and say, okay, I want to buy them. So he buys the 4 products. Then the next one comes, and now the stock is at 0, it's empty. I want to buy 2, but if we do that, we will have a negative stock, and that will not be feasible. So this is the parallel scenario that this is not the transactional way of doing it, that the first one will ask how much in the stock, and the next one will ask how much in the stock, and decrease by 4, decrease by 2, and then we have a problem. So we will look at it this way, that the first customer comes and begin the transaction and lock the table, so nobody else can come in and buy the stuff, and ask how much in the stock. Okay, I want to decrease by 4, and it's successful, and commit the transaction, so no problem. And then the next one comes and begin the transaction and ask how much in the stock, and decrease by 2. It's not possible, so we'll roll back the transaction and unlock the tables again. The last one is durability, and durability means that all committed transactions are stored, and this is not something that we usually would think of when we are working with transactions, because this is something that the SQL Server will take care of. And that means it will log everything. All actions are logged, so it's possible to track back transactions, and perhaps if the power goes off, then it's possible to roll back the transactions, or find out what is missing. So durability is about how to maintain a proper use of the transactions. Here we have a look at how we access the log in the SQL Server. And we can select, in this case I'll just select all columns from the sys database, and I would like to have the DB log. And it gives me something like this, and when you look at it, it's just mumbo jumbo. It's a lot of identifications and some statuses that doesn't make sense. if you like to dig into what is going on in this log, I can recommend this article about SQL tips for this transaction log. This is a website named mssqltips.com, and there's a very good article about how to read the transaction log in the SQL Server. So next is about how to do it in action. But before we go to that, I'd just like to recap that ACID is about atomicity, consistency, isolation, and durability. And by atomicity, we mean all or nothing. Consistency, respect the business rules. Isolation is about how we serialize our actions, so we don't get any actions that breaks the transaction. And then the durability is about how we store and log our transactions. So next is the transaction in action. So how do we do it in the SQL Server Management Studio? So we have this diagram of our tables. We have the order here, and an order contains some order lines, and an order line contains a product. And the customer is usually related to the order with the foreign key custom ID here. But in my example, I will try to demonstrate the principle of violating the business rules. So here, perhaps we forgot to create a constraint, or perhaps we don't have any constraints in this setup, the design. So in my transaction, I will try to maintain this constraint manually, just in order to demonstrate how is a transaction done. So I'll not go into a large demonstration here. I will just try to insert an order with a fake customer. That means a customer that does not exist. So is it possible to create an order with this customer ID that does not exist, just to see the possibilities of committing and rolling back. So let's have a look at how we will do it then. The first thing I will do is, of course, to use my shop database, and then I will go, and then I will create a procedure. So I will use a store procedure to contain this transaction code, and we will usually do that. We will put our transaction to a store procedure. So I will make a procedure, and I will name it Sprock create order, and I will just try to see if there's something working here. So I will print hello world, and if I just make it go, this one, and then I will execute my Sprock create order. So if I execute this, I get the message hello world. So we are in business. So the next thing I will try to do is just to see, is there any customers in my database. So I will select everything. I will only use the asterisk star for testing purposes usually. So this is for testing purpose. Everything from shop customer, and I will execute this. Oh, and I get this message that there's already an object named Sprock create order in a database. So I cannot, when I want to sit here and test and develop my transaction, I have to change this create to alter, because then I'm updating using this procedure. So I will execute it, and I can see I have one customer, and this customer has one ID. There's only ID number 1 existing in the database. So I would like to find out by passing a parameter into this procedure if it's possible to create an order without having the correct customer ID specified. So in order to get my parameter, I will here name it customer ID, and it will be an integer. And then I will begin my transaction. So I think this one, I'll just delete this. I don't need it anymore. And here I will begin my transaction. And when I begin a transaction, I have to commit it or roll it back eventually. So here in the end, I will make a commit transaction. So in between here, I can this is my area for doing the transaction, and right now I will only commit it. I will not roll it back. I will later on make some decision that if something happens, then I will commit it. Otherwise, I will roll it back. So the first thing I will do is to insert this this new order. So I will insert into shop order, and I want only to insert the customer ID, and it will be the values of my variable that I got, customer ID. So here it's possible for me to insert what I pass in the parameter. So let's have a look here. I think I will just make a select everything from shop order. So when I try to execute this, I get this this error that I did not pass a parameter here. So I have to pass a parameter, and this parameter should be the customer ID. So I will pass in 444 and have a look at that. So now I've created an order with the customer ID 444, and I know, and you know, that I don't have a customer with this ID. So right now I'm violating the business rules. So what can we do to check if there's a customer with this ID? Now I'm testing all my data or my transaction. So I will begin by delete from shop order. So I have a clean slate every time I run this procedure. So I'll do it again, and you can see here now it's the order ID increases by 1, 99, 100, and so on. So that is working. Now I want to check if this business rule has been violated. So I will make a select, but I would like to find out if there are any customers with this ID. So I will make here a new variable, and this would not be a parameter, so I will declare it inside this procedure. That means after the as keyword. So here I will declare that I'll call it check customer ID, and it will be also an integer. And here I would like to make a select. After I insert it, I will make a select customer ID. Actually, I need to select with the @ sign because I want to select a variable, or I want to output or the return value from the table will go into this variable. So it will equal that this customer ID I will retrieve, and it will come from shop customer, and I want to only get those with this customer ID that equals my parameter customer ID. So now I made a mistake. I will not select into this. This customer ID I will select into the check customer ID. So here I might have something I can work with, because now I get, if there is this customer, then I would like to I want to commit this transaction. Otherwise I will roll it back, because there's no purpose of creating a shop order with a fake customer. So here I would like to just print it out. Let's see what it is. Customer ID. And let's have a look. And here I will just omit this, so it's possible for me to see my prints. So I can see here I get 444. That means I actually, here again I need to check customer ID, not the customer ID. I know who's a customer because I specified it down here, but this one returns nothing. So I would like to, before I go, I'll just set the no count to on. Just a tip. So if I set no count to on, that means I don't have these one row affected and all that stuff. So as you can see here, I need to make it go afterwards. So now I have a blank sheet. So nothing is returned. That means it is false, what I get here. So now I can actually make an if statement. And the if statements in SQL goes like this: if, and then a parenthesis where we can specify the check customer ID. If it is greater than 0, that means we have some. Then we like to print out that we have success. Else we would like to print failure. So we can let go of these and then execute. Then we get a problem, because now we don't have a commit or a rollback. We only have the begin transaction, we don't have the end of the transaction. So we need to somewhere have this commit of the transaction. So I just leave it here just for now and see what goes on. It's a failure, nothing happens. So if we use 1, we have success. So let's have a look at how to do it with the commit and rollback then. So we would like to commit it. If it is a success, that means that the customer exists, or we would like to roll it back if it does not exist. And let's have a look here if it works when we have a customer that exists. Yes, now we have 126, 7, 8, and so on. And when we add a 1 here, we see that nothing happens. We don't get anything created, nothing inserted. This was set here at the beginning of our transaction, and try to select what if we had this customer ID, if it existed. And now, as we can see here, there's nothing nothing in my shop order table. That means everything has been rolled back because the customer ID does not exist. So that was just a short intro to how a transaction goes on. That in this case I put it into a stored procedure, and then I begin my transaction, and eventually I commit it or roll it back.